Yeah. Let's go to page 87, and this is section 6.6, and this is on Newton's sum. So the background of this is that you have to understand the notations. So S1 is a sum of the first degree roots. So S1 would be like your R1 plus R2 plus R3 plus dot 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 dot, whatever number of roots you have. Okay? S2 is R1 squared plus R2 squared plus R3 squared plus R4 squared plus dot dot dot. So S2 is a sum of the squares of the roots. And S3 would be R1 cubed plus R2 cubed plus R3 cubed plus R4 cubed. Okay, so S3 is the sum of all the cube of all the roots. Okay, and S4 and so forth and so forth. Okay. Okay, so you can S4 is the fourth power, the sum of all the fourth power of all the roots. Okay. Now, obviously, this is a very powerful technique, because imagine you have to look for all the roots, and then for the fourth power you have 4 roots, right? And then you're going to look for the 4 roots, and you have to fourth power, and you have to add all together. It's very complicated, and sometimes you cannot even do it. Right? So that's where the importance of the Newton's sum. It makes things a lot easier. Okay? And the way these things work is best thing to do is just go over some examples, because by explaining it's kind of very difficult. Okay? And the Newton's sum, here is a formula for the S1, for the S2, for the S3, for the S4. Okay, so here's a formula for that. Again, it seems very complicated, but it's best thing to do just go through the example. Okay. Okay, so let's go to page 88, and let's go over example 6-16. It says find the sum of the cube of the solutions. So it means you're looking for S3. That's what you're looking for. That's what it's asking for, right? Finding the sum of the cubes of the solutions. So that's a sum of the cube of the roots. So we're looking for these. That's what it's asking to do. Okay. So you have the x squared minus 3x plus 3 equal to 0. Okay. So again, since this equation is fairly simple, so normally you would just go and use quadratic formula, and you look for the 2 roots, and you cube it, and you add together, right? But sometimes if the roots are like imaginary, it can be messy. Okay. So this is how you write a sum. Okay. So you always start with S1. So S1. So what you do is you start with the first coefficient. So S1, you use the first coefficient. So in this case, it's 1. So 1, S1. So you just follow the coefficient. So whatever number of times, just follow the order. Okay. But the last one, you have to use this as a coefficient. So it'd be plus 1. This 1 came from here. Okay. Times negative 3 equal to 0. Okay. So again, you're going to have S1 and use the coefficient. So you're just using all the coefficient in order. Okay. So this coefficient is right over here. This coefficient is over here. But the last term, so all the coefficient will be the same except for the last term. So the last term, you have to multiply by this number over here. So that's the equation for your S1. Okay. For S2, so again, you're going to get 1. S2, right? 1 came from here. 1 S2 minus 3, actually plus negative 3, okay, S1, okay, so coefficient are just in order, so 1, negative 3, okay, and next one would be the 3, so you need to plus 2 times the 3 equal to 0. So again, the coefficient would be 1, negative 3, 3. Okay, and then you're going to get S2, S1, then after it's normal S, right? So normal S is your last term, which you have to multiply by this coefficient over here, okay? Now, if you were to look for S3, okay, in this case, that's what you're looking for, okay? So S3, you're going to get 1 times S3, okay, plus negative 3 times S2, right? Then you're going to plus 3 times S3, okay, S1. So again, 1, negative 3, 3, okay? Now that's normal terms. That means it's 0, okay? And then you have to times by the coefficient of this number over here, 3. Okay? So again, coefficient 1. And notice it's in order, it goes down in order, S3, S2, S1. Okay? So again, 1, negative 3, 3, and after that, normal numbers will be 0. So whenever it's normal number, it will be 0. Okay? So again, so 1, negative 3, 3, 0. Okay? And and after that, the last term, the very last term, you have to multiply by whatever this number is. Okay? And that's it. Okay? Okay, so now what you need to do is you have to start from here. You have to solve for S1, so you can substitute to look for S2, and you can substitute to look for S3. Okay? Okay, so from here, you simplify, so S1 minus 3 equal to 0, so S1 equal to 3. Okay, you substitute into here, so you get S2 plus negative 3 times 3 plus 6 equal to 0. So S2 minus 9 plus 6 equal to 0. So S2 minus 3 equal to 0. So S2 is also equal to 3. You substitute into here. So you got S3 minus, that's, okay, minus, let's do this. Okay, plus negative 3 times 3 plus 3 times S1 is 3 plus 0 equal to 0. Okay, so S3 minus 9 plus 9 equal to 0. So S3 equal to 0. Okay, and that's it. Okay. So again, let's do a couple more. Anyway, help to understand. So next one, let's go to page 89. Again, obviously, you can check your answers, right? You can, so, okay, let's go back over here. So you got x squared minus 3x plus 3 equal to 0. This is not factorable. So if you do it the normal way, then you have to have x equal to negative b plus or minus square root of b squared minus 4ac over 2a. So x will equal to 3 plus or minus square root of 9 minus 12 over 2. So you're going to have x equal to 3 plus or minus square root of 3i over 2. Then after that, you have to cube. So you got two answers, right? Again, this is square, so you got two roots, right? So you have to cube the positive roots. So you have to do this. So you have to 3 plus square root of 3i over 2. You have to cube that. You have to plus 3 minus square root of 3i. You have to cube that. Then you have to add this together. Then you get 0. Okay? So this is the normal way to do it. But the problem with this is, if this is like a 5th power, 6th power, it's going to be very difficult to find the roots, all 6 roots. Okay? Because anything higher than the 2 degree, then you have to use the division, your standard division. While some it's very difficult, or almost impossible to find all the roots. Okay? And that's why this is so powerful. Okay, anyway, let's go to page 89. And that's going to do the exercise 6-9. It says, so this is a very similar problem. Okay, it says find the sum of the cubes of the roots. Okay, now this is much more difficult. Like this one, this is quadratic. We can just use quadratic form to get that, right? But now it's a fourth power. Now it's almost like, almost impossible to find all the 4 roots, and you have to kind of, it's going to be very messy. Okay, so anyway, so you have 2x to the 4 plus 3x cubed plus x squared minus 4x minus 4 equal to 0. Right? You have to have equal to 0 in order to have a root, right? Okay. So again, so to find, so what are you looking for? You're looking for sum of the cube. So you're looking for S3. Okay. Okay, so again, let's go and write the equation. So start with S1. So you're going to get 2 times S1, okay, plus, okay, 1 from here. And the next coefficient is 3, equal to 0. Okay? So that's your S1 equation. Then S2 equation would be 2 times S2 plus 3 times S1 plus 1. And this number would be over here, would be 2 times 1 equal to 0. Okay? So again, when the coefficient number, the last term is the coefficient, the number, right? You have to multiply by whatever the S is. So the S3 would be 2 times S3 plus 3 times S2 plus 1 times S1, and the next number would be normal S, right? Because S3, S2, S1, so normal S. So next number, you have to times it by this coefficient and this number. Okay? So again, coefficient would be 2, 3, 1, negative 4, but the last one, with the one without the S, you have to multiply by this number right over here. Okay, so now it's just a matter of solving. So you got 2S1 plus 3 equal to 0. So 2S1 equal to negative 3. So S1 equal to negative 3 over 2. Okay? Substitute into here. So you got 2S2 plus 3 times negative 3 over 2 plus 2 equal to 0. So 2S2, so let's go on. So you got minus 9 over 2 plus 4 over 2 equal to 0. 2S2 minus 5 over 2 equal to 0. So 2S2 equal to 5 over 2. So S2 equal to 5 over 4. Okay, so it's substitute into here. So you got 2S3 plus, 3 times 5 over 4 plus 1 times S1 minus 12 equal to 0. So 2S3 plus 15 over 4 minus 3 over 2 minus 12 equal to 0. Okay. Now, one of the way you can do, instead, if you don't like the fractions, then you multiply by everything by 4 for now. Okay. So let's go and do that. So multiply by 4. So you're going to get 8S3 plus 15 minus 6 minus 48 equal to 0. So 8S3, let's see, 54, okay, equal to minus 39 equal to 0. And then move it over, so S3 so equal to 39, so S3 equal to 39 over 8. Okay, and that's it. So again, if you found all 4 roots and you cube each root and you add all those 4, the cube of those 4 roots, so you get 39 over 8. Okay. Okay, let's go to the next one. Now, the 4th power is still not too bad, okay? But when you get to the next example, go to page 90 and look at example 60-17. Okay, so now you see why you need to have using the Newton's sum. Okay, example 60-17 is if R1 R2 dot 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 R1000, so there are 1000 roots, okay, of the equation x to the 1000 power minus 10x plus 10 equal to 0. Find R1000, okay? So you have R1 1000 plus R2 1000's power plus dot 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 plus R1000. Okay. Okay, so you have this equation over here. So because this is a 1000 power, okay, so that means you're gonna get 1000 roots, and then you're gonna raise each root to 1000's power, and you're gonna add all that 1000 roots to the 1000 power together. Okay, so obviously it's I would say impossible to do it, regular way. Okay, so you must use Newton's sum, right? Imagine you have to solve this equation from 1000 roots, then you have to raise each root to 1000's power, then you have to add 1000 of those terms together, right? Okay, so what we're going to do is we're going to, again, obviously we're going to do, by the way, first if you expand this, right, this is x to 1000th power plus 0x to the 999 power plus 0x to the 998 power plus dot 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 dot, right? Then you have all the way until you get 1 power and then 0 power, right? So you got to kind of remember that. Okay, so when you start to write the Newton's sum equation, so you're going to get 1 times S1 plus, now all these are 0, right? So it'll be plus 0 equal to 0, right? So from here you can see that S1 equal to 0, okay? And then you do the S2, okay? You're going to get 1 S2 plus 2 times 0, 2 times, okay, S1, let's going to do that first. Okay, 0 S1 plus 2 times 0, okay? Okay, so you can coefficient, only if the first one is 1, rest of them is all 0. Therefore, all is going to be 0. Therefore, you can see that S2 is also equal to 0, okay? And you do the same thing, so you can see that S3 equal to 0, okay? Again, you're going to get 1 times S3 plus 0 times S2 plus 0 times S1 plus 3 times 0 equal to 0. So again, all this is going to be 0. Therefore, S3 is also going to equal to 0. Okay? So dot 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 all the way until you get to the very last one. Okay? So you're going to get 1 from here, the coefficient 1 times S1000 plus, again, the next coefficient, all these coefficients are 0. So you're going to be 0 times S999 plus 0. Again, all these coefficients are 0. Okay, times S998 plus dot 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 all the way until you get minus 10 here. Okay, I'm going to do plus negative 10 S1. Okay, so this is right over here. Now the very last number you have to multiply by the coefficient here, right? Okay, so it'd be plus 1000. This number came from here times the very last number equal to 0. Okay, but again, notice all this is going to be 0 until you get to here. Okay. Okay, so S of 1000 plus 0 plus 0 plus 0 plus all the way until you get to, all this would be 0 because S1 is also 0, right? See over here? So everything is all 0. Okay, plus until you get the last one, you get 10,000. Okay, so by moving this over, so S of 1000 will equal to negative 10,000. Okay, and that's it for this example. Okay, so again, this R1 to the 1000 plus R2 to the 1000 plus R3 to 1000, you add all together, will give you negative 10,000.